Okay, well, welcome to your first lesson in measurement for the preliminary course. So these couple of lessons are going to be based around accuracy in measurement and different things that can affect our accuracy, as well as some calculations to do with working out how accurate we are. So first of all, when we're talking about error, the actual definition that we have is the difference between the measured value and the true value of a measurement. So when you're using a measuring device, you can't actually be exactly 100% accurate. There are certain things that affect exactly how accurate you are, okay? So some sources of error could be the quality of the measuring instrument that you're using. For example, if you had a look at the ends of your ruler, if it was one that you maybe were using last year, you might find that the ends have been a bit rounded. And it might not start exactly at 0. Another source of error could be human error or parallax error, which is, say, for example, if you don't position yourself exactly over the top of the instrument that you're reading off, you can get some parallax error. Also the scale of the measuring instrument being used. So an example of that, if a ruler, say, has 10 centimetre markings on it, so that's the only markings that you have, they're 10 centimetres apart, and the object that you're measuring falls somewhere between two markings, then you would only ever be estimating the length. So you can't actually get an exact reading of something like that. Okay, so the scale can affect our measurement and the accuracy. Alright, the first term that you need to be aware of is something called absolute error. So you've probably come across this before in your junior maths. So the definition is the greatest difference between the measured value and the true value. So the measured value would be the one that you take. Okay? And the absolute error is the name given to the gap between the measurement you take and the actual value of the object. Now we get that by working out half of the smallest unit on the measuring device we're actually using. And you can see that symbol at the front there, that's a plus or minus. So we'll come across that a little bit later. So we'll look at 3 examples here. The first one, we've got some surveyor's tape. Now you can see the markings on this, so it's just been cut off either end. The markings, we've got 10 metres, 10.1, 10.2, etc. So you can see that our markings are 0.1 of a metre. Okay, and that's quite accurate for this device. So the smallest unit on the device, we would say, is 0.1 of a metre. That means that our absolute error is going to be plus or minus half of 0.1, half of the smallest unit. So that turns out to be 0.05 of a metre. Okay, so that measuring device is fairly accurate. Okay, the second example we've got is some bathroom scales. Now, even though we've only got the numbers 60 and 70 written on the scales, the markings that we have between them are what we're interested in. So each one of those markings would represent 1 kilogram, which means that's the smallest unit that we have. So our absolute error is going to be plus or minus half of 1 kilogram, which will work out to be 0.5 of a kilogram. Okay, the last example. So we've got a measuring cup. You can see the markings on the side there are every 50 mils. So the smallest unit that we have is 50 mils. To get our absolute error, plus or minus half of 50, which works out to be 25 mils. Okay, so that's how we get our absolute error. Now we then need to be able to go on and use our absolute error to get what we call the range. And you might see it called sometimes the upper and lower limits of our measurement. So the definition of that is the range within which the actual measurement lies. So we can confidently say that between these two values, the upper limit and the lower limit, somewhere in there is the true measurement of the object that we're measuring. Okay, what we do with the range, or how we work it out, the first step is always going to be to calculate your absolute error. Okay, which is what we just did before in those 3 examples. So find the smallest unit and then halve it. Your second step then is going to be firstly to subtract the absolute error from the measured value, so the one that you take, and then to add the absolute error to the measured value. And we're going to do an example of that because that can sometimes sound a little bit like gobbledygook. Okay, so an example here. Ron measured the length of his shorts to be 48 centimetres using the measuring tape that's pictured there. The question is, between which two values does the true measurement of the length of his shorts lie? So we're going to end up with the range, okay? But to get there, we first need to start by determining our absolute error. Okay, so we look for our smallest unit. Now the markings on here, 46, 47, 48, so we can see that those are 1 centimetre apart. That's our smallest unit. Therefore our absolute error is going to be plus or minus half of 1 centimetre, which is half a centimetre. Step 2 then, to find the range, which is this, between which two values does the true measurement lie, we will do the measurement subtract the error and the measurement add the error. So like this, we measured the shorts to be 48 centimetres. So we'll do 48 centimetres take away half a centimetre, 47.5. 48 centimetres plus half a centimetre, 48.5. So the final step then would be just to make the statement. Therefore, the true measurement of the shorts lies between 47.5 and 48.5 centimetres.